Hi, this is Linda from Great Glass Galore. Today I'm going to talk about the properties of glass as it heats and cools. Now this section you don't have to watch if you're a beginner fuser and you just want to put your project together and send it over to me or somebody else to fire it. But as you get to work with the kiln, if you're by a kiln, you'll want to know some of these properties. You can't just go and heat glass as fast as possible or cool it as fast as possible. There are many problems that can cause the glass to break. So I've made up a cheat sheet here. So we're going to go through the temperature ranges of the glass as it heats and cools. And a lot of these are general ranges. These temperature ranges can change depending on the glass brand, the glass colors, the COE, the coefficient of expansion. But really glass starts off as a solid. Okay, that means it's brittle. That means it can break from thermal shock. So you think about putting a Pyrex dish in an oven, it doesn't break, it heats slowly, it works fine. But if you put a Pyrex dish on a stovetop, it heats too quickly and it cracks. The same with glass. So you have to worry about, as you heat slowly, the bigger and thicker the project, the slower you have to heat it. Okay. Then we move on to the next section, which is 700 to 1,000 degrees Fahrenheit. This is where the glass starts to become a liquid rather. And it's like pudding. There are not too many problems as you go through this range, but then you get this next range, the 1,000 to 1,300 degree range. It becomes like taffy. This is where you can pull it or stretch it or slump it, but you also start to get bubbles between the layers. So if you think about baking a cake, the outside heats faster than the inside, or the inside lags. The same with glass. The outside will become more liquid first, start sticking together, and it could trap air bubbles in the middle. So you try and slow the glass heating rate in this range so that you reduce your bubbles. Then at 1,300 is when the glass is like honey and it starts to stick together. And the hotter we go in the 1,300 to 1,500 range, the more the glass starts to soften and meld into each other till it's one big full fuse layer. If you go beyond the 1,500 degrees, you run into problems with your glass getting so liquid it runs off your kiln shelf. So that's where you start damming your glass. And at 1,700 you can actually start raking or combing your glass, so you can go in with a tool into your kiln and start moving your glass around. Now we're getting into the cooling range. As you go from your full fuse or your beyond full fuse, your 1,500 down to 1,000 degrees, you can get a problem that's called devitrification. And this is a foggy film that builds up on the glass. And most major brands of glass, the Bullseye, Eurobor, Spectrum, OGT, have mostly, for the most part, gotten rid of that problem in their manufacturing process. But there's still certain colors you'll run into that have that problem, and there's two ways to get rid of it. One is to rapidly cool from full fuse to 1,000 degrees, so you skip that foggy range, which is around 1,300 degrees where that sets up. Or the other option is to put a devitrification spray. You spray it or paint it on the glass before you actually put the glass in the kiln, and that'll stop that from happening. So then you get down into your 1,000 degrees to 700 degrees. This is the really picky range because now the glass is turning back from the liquid to a solid. And there's really a big point in the glass. Again, I'm talking about like baking a cake where the outside is cooling faster than the inside. That happens with glass. But you want it all to go from all the molecules in the glass to line up and go from liquid to solid at the same time. So to do that, you really have to slow down the cooling, and you usually have an annealing temperature or annealing range where the glass molecules are going to set up as it goes from liquid to solid. So usually you'll go down to annealing point with System 96. The temperature is 950 degrees, and you hold that temperature, or another word for it is soak. You soak the temperature of the project so all the glass gets to the same temperature at the same time and can turn from liquid to solid at the same time. Okay? So, and of course, again, the bigger and thicker the project, the longer you have to anneal it. And once you anneal it, then you still need to slowly, after that, like 950 anneal temperature, go slowly to the strain point because it's still becoming a solid. It's still not fully solid. So usually with system 96, we'll go down to 800 degrees. If you look at system 90, the annealing temperature is actually 900 and the strain point is 700. So you still go slowly through that range. And then when you hit, again, after you get below that 700 degree range, again, these are all rough temperatures. This is where the glass is solid. You have to cool it slowly again. So that's the discussion of the heating properties. We're going to go on next to put the glass in the kiln, and I'll show you a sample glass firing schedule.